In this video, I'll be discussing projectile from a height. Projectile from a height. So here I can have three cases. So let's say I'm discussing case number 1 when I projected horizontally. Projected horizontally, like what I'm trying to say, it is like this. Suppose that there is a building or tower which has certain height h, like this, and what I have done, I just throw the ball like this. So of course you can see this ball will go like this. I am assuming directions positive, this direction positive and this direction positive. So normal y and x directions, right? So my question can be like, for the understanding purpose, we need to find the time and how much time it will reach from point O to point A on the ground, right? So what I can do, I can use s is equal to ut plus half at square, right? But in y direction I am using, so now here what is known for us? So known parameters are, as you have provided the velocity ux is equal to u, so in vertical direction uy is 0, here ux is u which I provided, so now I can write uy is 0, ay is simply, this direction is positive, upper one, so this will be minus g because gravity is downwards, right? So ay is this much, and of course uy is 0, and sy I am talking about, so that would be minus h. Now substituting these value, so I get minus h is equal to 0 into t plus half into minus g into t square. So this will be minus h is equal to, this is 0 minus half gt square, or minus half gt square can be written as minus h. This is cancelled out, so t can be written as under root of 2h by g, correct? This is going to be the value of time. So if we have achieved this value, then I can also calculate the horizontal displacement, which is simply the range here. So horizontal displacement r is given by simply ux into t. Obviously there is no acceleration, right? So I can write sx is equal to r, so this is nothing else sx, so r is equal to ux is ut is under root of 2h by g. So that's how we can calculate the value of range also. Now u is known, h is known, g is also known, we can find easily. Now case number 2 will be here. When we have projected, this is certainly at an angle alpha or theta upwards. So case number 2, projected upwards at an angle alpha from a tower. So suppose the situation is this time, this is the horizontal, this is our tower which was the same height h. Now this particle is projected like this with velocity same u. Now of course you can see that this particle will have the projectile motion like this, correct? Again this was the point O and this was the point, let's say A dash. So now this time particles is at A dash, so this time it covers the separate range which is let's say R in this case, and of course this time from time to O to A will be this. t again. So now how to calculate this t? So this time what I have to do, I need to again similarly write this angle is alpha, so this is ux, which is u cos alpha only, and this will be uy, which is u sin alpha. Correct? Now again you need to think which velocity is responsible in particle in taking up. So uy is the velocity, uy is the velocity by which particle goes up. So as this is the velocity, that means what will happen, at certain point this uy will be 0. Obviously this is a point when uy will be 0, and then particle goes back. So what I can do here, I can again apply, again I'm taking the directions, which one positive. So in y direction upwards positive, and in x direction positive, x as positive, same. Now we can apply sy is equal to ut plus half at square, but of course in y direction. Now what is known for us? So what is available data here, which is sy, which is minus h, and ay is equal to minus g because gravity is in this direction, and of course uy is u sin alpha because that is the only thing which is in positive direction, right? So we can substitute the value. So minus h is equal to u sin alpha into t plus half ay is minus g into t square, right? So we get the equation here, t square gt square by 2 minus u sin alpha into t minus h is equal to 0. So we are achieving a quadratic equation here, and then we have to solve the quadratic equation, and then only we can find out the answer, right? So time we will be achieving, and then obviously for range, what I can do here, range, the range is going to be r, which is simply v ux into t. So of course ux is achieved by us, which is simply u cos alpha, and t is obviously the result of this quadratic equation will give the answer. And slight change in this part only, and which will lead to the third variation. So what I have done this time we have projected at an angle alpha but downward direction like this. So this is the alpha angle, right? So velocity is simply u, and then point is a double dash, right? So the range which we had earlier, this r, now the range will only left out to be this r, right? And here again we have to do the same things, but this time our data will vary because because of the sign convention, data has to vary. So what will be this time? So clearly you can observe here sy will be minus h, that is fine. Uy, so this time uy is like this and ux is like this. Similarly u cos alpha and u was y u sin alpha, but the direction of ui is changed, so this will be u minus u sin alpha. So that would be the change, and obviously ay is same. So once I substitute the value, so minus h is equal to minus u sin alpha into t plus half minus g into t square. So this minus can be removed here. So then we achieve gt square by 2 plus u sin alpha into t minus h is equal to 0. Again we are obtaining a quadratic equation, right? Quadratic equation that can be solved easily. So this time I am just writing the result. So this will be t square plus 2u sine alpha by g into t minus 2h by g is equal to 0, right? This is going to be the function of t. So this time we can find out the result for t also. So this t is equal to minus b plus minus under root of 4 b square minus 4ac upon 2a. So minus b minus 2u sine alpha by g plus minus root b square, which is 2u sine alpha by g whole square minus 4a. A is 1 and this is minus 2h by g upon 2 into 1. So this is going to be the value of t. In fact, you can solve these things, which is not at all tough here. So now similarly we can obtain the value of range, which range will be simply r, which is ux into t. We already achieved the value of t, so rh u cos alpha into t, that would provide you the final answer. Okay, so that's how we solve projectile motion from a particular height. Okay, yeah.